Hey folks, welcome to my channel Number Pen. So today we're going to look at a few examples on how to use the graph to find the limits, right? Yeah, in my previous video we saw a few problems on limits. Now those were very simple problems. Now whatever we're going to see today uh, is also going to be very simple, when it comes to understanding limits. So I have picked this up directly from the textbook, and I thought it's much easier to look at these graphs straight from the textbook and understand how do we arrive at limits by looking at graphs, right? So you have two graphs in front of you, and the one on the left, which is, let me use the draw pen so that, right? So we're looking at this graph, right, which is limit as x tends to 3 is 4 minus x, right? And you have the graph in front of you on your left, right? So when we look at this graph as x tends to 3, we've been asked to find if there is a limit, right? And the graph of this function is 4 minus x, right? So the way to do this is quite simple. When you observe the graph very closely, you see a dark dot at the point 3, right, which is where we've been asked to find the limit. And this graph includes the point 3, which is what it means because it's a closed dark circle, right? And let's assume that we pick up a value which is very close to 3 and let it be this point. And on the right hand side, let it be, say, this point, right? You still notice that we get very, it takes a value 1 as we get very close to 3, right? And if you recall my previous video, to determine if a limit exists or not, our right hand and the left hand side limits will have to be equal, right? And in this case, uh, we see that they are equal as h tends to 0, right? Or as the x value of x gets very close to 3. So let me just rewrite it in the manner we wrote it yesterday. So 4 minus x is 4 minus 3 plus h, right? And let me do it as 4 minus 3 plus or minus h here because we'll try and denote both the RHL and the LHL in the same working, right? And h tends to 0, you have 1, right? So this graph tells us that there is a limit that exists for this particular function as x tends to so it exists, right? Let me call it e. Let's move to the graph on the right hand side, and which is nothing but the graph of a parabola, as you all familiar with, which is x square plus 2, which hits the x axis at x equals which hits the y axis at x equals 0. And as you can see that you will see this dot here, which is a closed dark circle, which means that this graph includes the point x equals 1. And we'll do something very similar to what we did in our previous problem. As x tends to 1, we have the limit as 1 plus or minus h, the whole square plus 2, right? So as h tends to 0, we know that this takes the value 3. And it's very evident from the graph as well, right? Now if I take a number which is very close to 1, say lesser than 1, on the left hand side of this circle, it's still approaches the value 3 on y. And similarly, if I'm going to take a point on the right hand side of x equals 1, then we know that it still approaches the value 3, which is what is given by this working here. So I'm not going to go into the details of this working in this particular video. It is primarily to understand how to arrive at limits by looking at graphs, or more so in and interpret them. So with this, we'll move to the next set of graphs. These are quite interesting, and this is where I want to draw your attention to. So we look at uh, graph on the left hand side. So this is the equation of this graph, where f of x equals 4 minus x when x is not equal to 2, and it is 0 when x equal to 2. And let's see how this is represented in the graph first, right? So you know that 4 minus x is a straight line, right? So when x equals 0, then it hits the x-axis here, and when y equals 0, x equals 4, which means that it hits the y-axis here. So this is how the graph is represented. But what distinguishes this graph from a normal straight line is the equation says when x equals 2, which is this point, right? What it says is it takes a value 0. It is no longer taking a value equivalent to 4 minus 2, which is equal to 2, which otherwise would have been the equation of, would have been the value of y on the straight line, right? So it means we represent this by an open circle here on this graph. Like you can see at the point 2, you have this open circle, which I've squared this for you here, right? And let me write this up so that open. And the corresponding point here is represented as 0, which is what is coming here, which you will see your dark closed circle. And let me write this out here, which means that the function 4 minus x, x not equal to 2, and function f of x equals 0 when x equal to 2 is represented in this graph using this open and closed circle at the point 2. And at all other points, it is a straight line, which is represented by the equation 4 minus x. So I'm not going to do the working out here, unlike the earlier problem. Here, what you can see, as x takes a value very close to 2, it will fall into 4 minus x, right? Now let's take a value of 4 minus, uh, say, 1.99, for example, right? You see that it takes the value 2.01, which means that it takes the value 2, which is nothing but your 4 minus x as x tends to 2, right? And what we've been told is at x equals 2, right? This takes the value 0, right? Now we have another case here. Let me take a value of, let me rub this out, and let me take a value 2.01, which is on the right hand side of 2, which is again going to lead me to 4 minus 2.01, which is my 1.99, right? So which is again very close to 2. So what we see here is when we take a value which is not 2 but very close to 2, and it be the left hand side or the right hand side, it tends to take the value 2, right? It tends to take the value 2. But at x equals 2, it is not taking the value 4 minus 2, which is 2, which actually means that your right hand limit and the left hand limit are equal, which is basically the condition required for a limit to exist. So, which means that the limit does exist for this graph. Let me call this as E. right? But then it is not equal to f of 2, which is because f of 2 is 0, for this particular graph or for this particular equation, right? So which means that it still has a limit, and I'm just drawing your attention to what we discussed in my previous video. And if you have not watched it, please do take a look at it, like a look at my video, Introduction to Limits. You will see that the condition for limit to exist is f of uh, the right hand side limit equals the left hand side limit. And what it actually means is, as x gets close to 2, as far as this particular graph is concerned, it takes equal values, right? And which is what we are seeing in this particular graph, which means that the limit exists, but it is not equal to f of 2, right? So what does it mean? It actually means that the function is discontinuous at the point 2. Now I'll stop it here and I'll take this topic again when we discuss continuity of a function. And this is one of the primary reasons I wanted to discuss limits first before we go into continuity, right? So, so in this particular case, to conclude, the limit exists for this particular function f of x. Okay, because it many of the students could go wrong here. They might assume that this function does not have a limit, but it actually has a limit. But it's just that it is not continuous at the point where we've been asked to find the limits, right? So I'll probably move on to the next graph. And here we have a very similar situation, right? So without much of explanation, this is again the graph of a parabola. But the difference here is at x equals 1, the graph does not follow the parabola. It takes a value equals 1, which is what is shown by this closed circle here. And at x equals 1, it is not a part of x square plus 2, which is the parabola, which is shown by the open circle here, right? So this is what, you know, I just probably highlight this here, right? So which means at x equals 1 plus h or 1 minus h, I'm going to have the value 1 plus or minus h, the whole square plus 2, right? So which means this takes the value 3, which is what you can observe from this graph here. For values very close to 1, this number is 3 on the y-axis, right? And you can check this out by substituting a number which is very close to 1. So f of 3 plus h, which is a value very close to, sorry, f of 1 plus h, which is a value very close to 1, is equal to 1 minus h, which is again a value very close to 1 but lesser than 1. But it's not equal to f of 1 because the function takes a value 1 at x equals 1, right? So here again, limit exists because your RHL equals LHL, your right hand limit equals left hand limit, but the function is not continuous at the point x equals 1, right? So I hope you had a good understanding of these two problems. With this, I'll move on to the next set of graphs which we have on our next page, right? So let me come here. So if you go back to my earlier video, you will see an example 1 by x. This is something very similar to that. You have 1 by x minus 3, and we know that at x equals 3, it becomes infinite, right? And at x equals minus 3, I'm sorry, at x equals 3 plus h, which is a value which is slightly greater than 3, we will see that this function takes plus infinite, right? And when x takes a value slightly lesser than 3, which is here, we know that 1 by x minus 3 is going to take a negative value, and it values very close to 3. This takes minus infinity, right? This is because x could take a very small value, say 2.99999, just for an example. So 1 divided by x minus 3 becomes a negative, and as x tends to 3, it is going to tend to minus infinity. So you will see that there is a break here at the point x equals 3. And at x equals 3, this becomes infinite. So again, going back to the definition of existence of limits, here we have right hand limit not equal to left hand limit, right? Because this is plus infinity, your right hand limit, and this is minus infinity, your right left hand limit, right? So the limit does not exist here, right? So no limit for this function. I'll move to the next one, again an interesting problem, which is mod of x minus 5 divided by x minus 5, right? So what you see on your right is the right of the page is the graph of this particular function. So x equals 5, it is an indeterminate, right? So which is why you see these open circles here at 5, right, for both the lines. So that's point number one, which means that the graph, the function does not exist, or the function is indeterminate for x equals 5. That's point number one. And point number two is for values x greater than 5, which is your this portion of the curve, this portion of the graph, we see that x minus 5 becomes positive. So x minus 5 equals x minus 5 divided by x minus 5, which is nothing but 1, right? So the graph is a straight line for all values x greater than 5. It's a straight line, which means y equals 1, right? And for a minute, let's do the same thing with values lesser than 5. And what do we arrive at? For values less than 5, we know that the mod function will take minus of x minus 5, right? And why is that? Because mod of any function is always a positive number, and an x minus 5 is going to take a negative number because x is going to be lesser than 5. We'll have to represent it as minus of x minus 5, which is, you know, your numerator becomes 5 minus x divided by your denominator, which is x minus 5, which is your minus 1. I cancel this x minus 5 out, right? So which is where you see this graph here. For x less than 5, it takes a value minus 1. So we will go back and apply the limit existence condition. So your f of RH hell, which is your right hand limit, is 1, your left hand limit is minus 1. So which means this function, the limit does not exist, right? I'll come again. We'll move to the next set of graphs. So these are trigonometric functions. So you have sine pi of x and x tending to 1, right? So this is the point where you've been asked to find if the limit exists or not. So this is a no-brainer. You see that sine of a function is continuous, right? And it is a bound function. It takes values between minus 1 to plus 1, right? So this graph, as you can see, for values very close to 1, you still see that the sign of function remains the same, be it x tending to 1 plus h or x tending to 1 minus h, right? So it's basically limit exists. Now, about a secant of x, which is your next graph, which you can see this is a question we have. Secant of x, another uh, interesting question. So, what we see is that secant of x, right? Now, here again, at x equals 0, which is nothing but this point, right? We see that for values very close to 0, you still see that the graph will take the value 1, right? And for values which is very close to 0 on the right hand side, this graph takes the value, still takes the value 1. And for values very close to 0 but approaching 0 from the left hand side, this function still takes the value 0, right? Still takes the value 1. So the limit exists for this particular function as well. And what is the limit? The limit is 1. And in this question, the limit is 0, right? Because sine of 180 is 0. This is the last graph of today's video. And this is nothing but your tan x function, right? So something very similar to the mod function which we saw earlier, or the 1 by x minus 3 function what we saw earlier. So we've been asked to find what is the limit at x tends to pi by 2. So tan function lesser than pi by 2 for values which are very close to pi by 2 is indicated out here, which is tending to plus infinity, right? And for values which are very close to pi by 2 but greater than pi by 2, we know that the tan function is negative. So it takes the number minus infinity, right? So which means at pi by 2, these two limits are not equal. Your left hand limit takes the value plus infinity, your right hand limit takes the value minus infinity. So we have the limit does not exist, right? So that's all we have in today's video. And I hope you had a good understanding of how to approach, or rather, I would say, how to understand limits by looking at the graphs of various functions, right? And thank you for watching my channel. Please do subscribe, and happy to receive feedback and comments on my videos. Have a good day. Thank you.